So we've looked at how you solve equations that have square roots in them. Now what we're going to look at is how do you solve an equation where there's a square root on both sides of the equation, okay? So you can kind of see here, right, both sides of the equation have square roots. So basically what we're going to do is the first thing we're going to do is we're going to square both sides of the equation, okay, because squaring and square rooting cancel each other out. Then we'll solve whatever equation's left. And then just like we did before, we have to check our solution, okay? Remember we talked about extraneous solutions? Okay, so we want to check and see what's going on with that. So let's start with this guy. So step one, I'm squaring both sides of the equation. Now squaring and square rooting cancel each other out, right? So this is going to cancel and that's going to cancel. And I'm going to be left with just 3x plus 5 and then 5x plus 1. The squaring and square rooting cancel each other out. Okay, and now we're just going to solve this like a regular equation. So our next step is we want to get all the variables together. So I'm going to subtract 3x from both sides, so those will cancel. All right, that leaves me with a 5 over here. 5x minus 3x is 2x, and then plus 1. We could have also subtracted 5x from both sides. It doesn't matter. It works either way. Okay, so then from there, I'm going to subtract the 1 from both sides so that these guys will cancel. So 5 minus 1 is 4. And finally, divide by 2. So we have the x by itself. So we have x equals 2 as our answer. Okay, but we're not done yet, right? Because now we have to check our solution, because sometimes, even if you do everything correct, sometimes you'll still get an answer that's not really an answer to your equation. Okay, so let's check. I'm going to go back up. I'm going to rewrite this equation. Then I'm going to plug in the 2 for the x. So it's going to be the square root of 3. And then I'm doing, instead of times x, I'm doing times 2 plus 5. And we want to know, does that equal the square root of 5? And then again, 2 instead of the x plus 1. And we're just going to check and see if it works out. So 3 times 2 is 6. So this is the square root of 6 plus 5. And 6 plus 5 is 11. So on that side, we got a square root of 11. And on this side, 5 times 2 is 10. And 10 plus 1 is 11. Does the square root of 11 equal the square root of 11? Yep, it does. So we are all set. This is actually our solution to this equation. All right, so now let's do the same thing with our next equation. So again, first step is we're going to square both sides, right? Because squaring and square rooting cancel each other out. And that leaves me with x plus 2 on this side and 2x plus 6 on this side. You want to get all of the x's together, so you can either subtract 1x from both sides or subtract 2x from both sides. It doesn't matter. I'm going to subtract the x from both sides, so those will cancel. So that leaves me with 2 equals 2x minus x is just 1x plus 6. And then I'll subtract the 6 from both sides and get negative 4 equals x. All right, so we've got our supposed answer. Now we got to go back and check it and see if that's actually our answer. So let's try it. So we're going to get the square root of, and then I'm going to plug in negative 4 for x plus 2. And we want to know, does that equal the square root of 2 times, again, putting in negative 4 for the x, plus 6. All right, and let's check and see what happens. So negative 4 plus 2 is negative 2. So I got the square root of negative 2. And on this side, I'm going to get, see, 2 times negative 4 is negative 8. And then negative 8 plus 6 is negative 2. So we did end up with something that appears to be true, right? We got the square root. It's the same thing on both sides. So it kind of looks like it's true, right? But we have a problem because you can't take square roots of negative numbers. Remember, square roots are asking you what times itself equals this number, right? There's no number times itself that could ever possibly equal a negative number, okay? It's not possible. If you try to put the square root of negative 2 into a calculator, you're going to get an error, okay? You can't take square roots of negatives. So this is a problem, okay? And this is my cue that this is not actually a solution to this equation. And since it's not, and that was the only possible answer that we found, that tells me that there is no solution to this equation. Okay, so when we went to check our answer, even though we did all the steps right here, we ended up with a square root inside of a negative, and you can't take square roots of negative numbers. Okay, so that's how I knew that this is not an answer and there's no solution to this problem. Okay, so let's talk just a little bit more about those answers and what happens. So this is called an extraneous solution. So the -4 here is an extraneous solution. Okay, so what that means is that there is an answer that's not really an answer to the equation. You did everything right, but that doesn't actually make your equation true. So answers are extraneous, or there is no solution in this case. Okay, when there is either a negative number inside of the radical, or if your radical equals a negative number. Okay, and we looked at that a little bit before, but like an example of that would be if you got like the square root of 4 equals a -2. So I have a square root that equals a negative number. Okay, or like on this one, it would be like when we got the square root of -2. So you can't have a negative inside and you can't have it equal a negative. Okay, so those are going to be your cues. Now, there are other ways that you can get extraneous solutions to things. Okay, and sometimes having an extraneous solution doesn't mean there's no solutions. Sometimes when you solve an equation like this, you'll end up with two solutions. And it might be that there's two answers to the problem, or it could be that only one of them's an answer and the other one's extraneous. Or it could be that they're both not solutions and it's still no solution. Okay, so it's possible for a bunch of different things to happen. But for this course, we're really just going to focus on kind of what's happening here. We're going to have one answer, and you have to decide if it's a solution or not, and say that there's no solution if it isn't. Okay? There are other ways to get extraneous solutions other than just these two. But for this course, these are the two that we're really going to focus on. Okay? So that is how you solve a radical equation where there's a radical on both sides. You square both sides to get rid of the radical, solve your equation, and then just don't forget to check your solution, because sometimes even if you do everything right, your final answer still works out not to make the equation true.